Hi folks, today we're going to review for Unit 4 Test 1. It's over cubic and cube root functions with the transformations of the parent functions. So the way that this review works in the Desmos activities is if an angry emoji appears, which is red, then you're not correct. And if a happy emoji appears, then you're correct and you can move on. It's a good idea to use your notes while you're doing the review to help you complete it correctly. So let's move to the first. Whoops. There we go. It says fill in the table with the key features for the equation. So the first thing that we need to do is identify the key attributes of the cubic parent function. And then the second thing that we're asked to do is to use the graph to the left to sketch the cubic parent function. I have given you the cubic parent function right here. So we have f of x equals x cubed. Now actually, instead of doing the key features first, I'm going to go ahead and do the graph first so that I can get my key features from there. So I'm going to change my color here. I'm going to make an x and a y. Probably should have made a process column too, but that's okay. So let's see, maybe -2, -1, 0, 1, 2. Those are going to be my x values, and what I need to do is I need to cube those x values in order to get the y values. So if I have -2 cubed, -2 times -2 is positive 4, and then times another -2, that's -8. Notice that my signs are the same. If I take -1 and I cube it, I get -1. 0 cubed is 0. 1 cubed is 1. And 2 cubed is 8. So now I'm going to go through and I'm going to plot the points that I have from my table that I created. So let me move this up a little bit. There we go. -2, -8 would be here. -2 and -8. And -1, -1 here. 0, 0. 1, 1. And 2, positive 8. So here is my graph. Of my cubic parent function. Oops, sorry. There we go. So now I'm going to go ahead and go over to my keyboard and I'm going to type in things that I think match the key features. Now, if you don't know how to type in these key features, I give you kind of the format above. So the vertex, type it as an ordered pair with no spaces. Domain and range, type the words, and so on. So for my vertex, well, my vertex is that point where it's changing, that turning point. So that's at the origin. That's at the point 0, 0. Notice how my emoji changed to a happy one, so that means I'm right. My domain, well, from left to right, I don't have any boundaries. In fact, I've got a arrow here, and then over here I also have an arrow. So that tells me the domain is going to be all real numbers. Make sure I spell it right. If I spell it wrong, then I'm going to get the unhappy emoji. The range from bottom to top, again, I've got an arrow on the bottom and an arrow pointing to the top, so I don't have any boundaries. My range is all real numbers. The Y-intercept, the place where the graph is crossing the y-axis, would be here at 0, 0. And then the x-intercept, the place where my cubic is passing the x-axis, would be again right here at 0, 0. So I've got all happy faces. I've typed everything in the way that I was asked to type it in, following that format. I've sketched my graph. I'm moving on to the next problem. The next problem asks me to fill in the table with the key features for the equation. This time I need to identify the key attributes of the cube root parent function and use the graph to the left to sketch the cube root parent function. So I have f of x equals the cube root of x. Again, instead of doing my key features first, I'm going to graph first. So I'm going to change my color. Maybe I don't want that dot there. All right, so x and y all the way down. Okay, that might actually get in my way in a minute, maybe not. Whenever I pick my x values, it's important to pick values that can be cube rooted, because I'm taking x and I'm cube rooting it. So if I pick like -2, which is the first x value that I picked in my last problem, I can't cube root -2 without getting some kind of ugly decimal. And so what I want to do when I pick my x values is I want to pick values that I can cube root. So maybe I pick -8 because the cube root of -8 is -2. And maybe I pick -1 because the cube root of -1 is -1. And maybe I pick 0 because the cube root of 0 is 0. The cube root of 1 is 1. The cube root of 2 is not a nice pretty number, so I need to go to the next thing that I can cube, that I can cube root. So I want to cube root 8. The cube root of 8 is 2. So I have these points, and I'd like to plot them. So I have -8, -2. Here's that point. I have -1, -1, 0, 0, 1, 1, and 8, +2. So here is my cube root parent function. Okay, I'm going to head on over to my keyboard so that I can type in the key features here the way that I'm asked to. Let me scroll down a little bit. My vertex, my turning point, is right here in the center. That would be the origin, 0, 0. Notice how if you leave off a parenthesis, the "Are you correct" column still shows an angry emoji. So make sure that you complete your ordered pair with parentheses. Your domain, from the left to the right. I can't put a boundary on the left because there is an arrow. And I can't put a boundary on the right because there's an arrow. So it goes on to infinity in both directions. That's all real numbers. The range, bottom to top. Well, the bottom has an arrow and it keeps going down. The top has an arrow and it keeps going up. So again, my range is not bounded. It's all real numbers. The y-intercept, the place where the graph crosses the y-axis, would be right here, boom, in the middle at the vertex. So that's 0, 0. And then the place where the graph crosses the y-axis would be, again, right here at 0, 0. Okay, so I'm going to move on to my next question. The next question says, find the required information for the equation. I need to find the x-intercept and the y-intercept of the following functions. And I'm supposed to show my work in the box to the left, so this box over here. All my work will be shown here. Here's my equation. Here is the way that I'm supposed to type in my answers, so they're ordered pairs with no spaces. I'm going to go ahead and put my kind of format, parentheses with a comma in between. And I know that the x-intercept is an x value, but the y value is always going to be what? 0. So let's start out with that idea whenever we're trying to find the x-intercept. Ooh, that doesn't look like a 0. What is that? That almost looks like an O. There we go. Okay, so if my y value is 0, well, let's see. X-intercept. If my y value is 0, I'm going to go ahead and put 0 in place of g of x, because that's really where y is supposed to go. Equals the cube root of x minus 8. Well, we remember that the opposite of cube rooting is to cube. And so I'm going to take both sides and I'm going to cube both sides. Because what I do to one side, I do to the other. So 0 cubed is just 0. And if I cube a cube root, well, I no longer have the cube root. I just have x minus 8. I bet you could finish solving for x. If I do inverse operations to both sides, I end up with an x value of 8. So I would go back to my keyboard and I would type in 8 for my x value in my x-intercept. And look at that, we're correct. All right, for the y-intercept, it's a y value when x is what? 0. So I have to go take 0, substitute it for x, and see what my y value is going to be. So I'm going to change colors. Green sounds good. Y-intercept. So in my y-intercept, I'm looking for the y value when x is 0. So y equals, that's kind of like g of x. equals the cube root of not x minus 8, but 0 minus 8. And what is 0 minus 8? Well, it's negative 8. And if you cube root negative 8, think back to our previous problem, what is the cube root of negative 8? It's negative 2. So I'm going to go back over to my keyboard, and I'm going to type in negative 2. And we got it. We got the intercepts. So we got these by taking 0 and substituting it into the function where it belongs. So if we're looking for the x-intercept, you're solving for x when y is 0. If you're looking for the y-intercept, you're solving for y when x is 0. Now, I'm asked to find the x-intercept and y-intercept of this function, and I need to show my work in the box to the left. I'm going to go ahead and write in my ordered pairs. So in the x-intercept, my y value is 0. So I'm going to go to the work box, and for my x-intercept, 0 is my y value. So I'm going to substitute 0 for y. 0 equals x cubed minus 27. I want to isolate the variable, so I'm going to do inverse operations to move the constant. So 27 equals x. Ooh, no, what is that? That's not what I want. Let's see. There we go. Sorry, I don't know what that was. Let's go ahead and erase that giant long line. Okay. So we have x cubed equals 27. Well, we just talked in the last problem, what's the inverse of cube rooting? Cubing. So if I want to undo this cubing that's happening, I need to cube root. So my cube root and my cube will go away. I'll have x equals, and the cube root of 27 is just a positive 3. So I'm going to go back to my keyboard. I'm going to type in a 3 for my x value, and I'm going to hope that I get a happy emoji. Oh, it would help if I typed it in the correct place. There we go. Looks good. So now I'm going to move on to the y-intercept. The y-intercept is the y value when x is 0. And I don't know why that keeps moving, I'm sorry. So I'm going to go change my color. I'm going to find the y-intercept. So the y-intercept is when x is 0. So y equals not x cubed, but 0 cubed minus 27. Well, 0 cubed is just 0, and 0 minus 27 is negative 27. So I'm going to go over to my keyboard, and I'm going to type in for the y value, negative 27. There we go. Wonderful. So again, substituting 0 where it belongs. So we might need to find information about the maximum and the minimum. The maximum and the minimum should just be typed in as a single number. It asks us to show our work in the box to the left, and they're asking us to find the maximum and minimum of the cubic parent function, f of x equals x cubed, on the interval from negative 4 to 3. Now remember, what this means is that we are restricting the domain. Restrict domain. That also means that the interval from negative 4 to 3 are x values. So whenever we substitute negative 4 and 3 into our function, we're going to be substituting them for x. So first, it doesn't matter. First, let's do negative 4. So I'm trying to find f of negative 4. Well, if I have negative 4, and I cube it, That's negative 4 times negative 4, which is 16, times another negative 4, which is negative 64. So there's one kind of extreme value. It's either a maximum or a minimum. We're not sure which one yet. So let's go ahead and find the other one. Let's find f of the other boundary, which is 3. So I'm going to take 3. I'm going to cube it. 3 cubed is 3 times 3, which is 9, times another 3, which is 27. So now you have to decide between these two, this one and this one, which one's the maximum and which one's the minimum. Well, obviously, the maximum is going to be the bigger of the two numbers. So the maximum is going to be 27, and the minimum is going to be negative 64. All right, we only have 2 more questions in our review today. This one is about transformations. It says, given the parent function f of x equals x cubed, that would be the cubic parent function, select the written equation for the given transformation, describe the transformations, and graph the transformed function on the graph provided. Well, on the graph provided, I'm going to go ahead and sketch my cubic parent function. So I have points at -1, -1, 0, 0, 1, 1, 2, 8, and -2, -8. So these are kind of my original parent function points. Now, remember that whenever we're transforming into like a specific equation from this general transformation equation, we need to make sure anything inside parentheses either gets cubed or cube rooted based on the type of problem. Well, this is a cube problem, a cubic problem. So we'll make sure to cube anything in parentheses, and then anything outside parentheses needs to be either before or after the cubing. So this -2 in front needs to be out in front. Well, it's out in front in the first choice, the second choice, the third choice, and the fourth choice, so that seems okay. The +3 needs to be at the end. We've got +3, +3, +3, +3. This all looks fine. But now the x minus 6, that needs to go in parentheses and it needs to be cubed. So here, x minus 6 is not being cubed. That can't be our answer. Here, x minus 6 is being cubed. That looks good. Here, x is being cubed, but then we have -6 after the cubed, and that's not right, because -6 isn't outside of parentheses. And here we have x minus 6, but it's being cube rooted, and that's not the function that we are transforming. So our correct answer would be the second one. And you would explain your thinking here. You would give me some kind of summary about things in parentheses being cubed and things outside parentheses, being where they are. Now, we need to determine the transformations that are happening, because if you look over on the right side, there's all of these possibilities. And you have to check the right ones, because if you check any of them that are wrong, or if you don't check one that's happening, then you're going to get this question wrong. So let's talk about the things that are happening. The first thing that I see is this negative outside. Well, this negative outside is vertical, because anything outside is a vertical change. So if I'm reflecting vertically, that's over the what axis? That's over this x-axis here. So I'm reflecting over the x-axis. Shifting. I have +3 outside, so that's vertical. That means I'm moving up 3. So I'm going to go find up 3. Shift up 3. I have -6 inside. -6 inside of parentheses. So that means it's horizontal and a lie. So I'm really shifting 6 to the right. So I'm going to go find 6 to the right. And then the last thing that I have is this this 2. The minus was a reflection, but the 2 outside, that's the coefficient, that's vertical because it's outside. And you have to determine if it's a stretch or a compression. Now, if things are being multiplied by 2, they get bigger, so that would be a stretch. So I'm going to go find vertical stretch by a factor of 2. And I also want to make sure that I'm transforming. So I'm going to do the things that are inside of the parentheses first. I'm going to take this origin, I'm going to shift it 6 units to the right. So here's the new origin. And then I want to flip it over the x-axis, so I'll do that in a moment. I'll stretch it vertically, but I also need to shift it up 3. So 1, 2, 3. That is my new vertex. So here is my vertex. We decided that we need to reflect over the x-axis. So that means that instead of starting at the bottom and going to the top right, we're going to start at the top left and we're going to go to the bottom. And then we're stretching by 2. So instead of going over to the right 1 and up 1, we'd go over to the right 1 and up 2. Okay? So I stretch, and I probably won't be able to fit the other one on the graph because I would have to go over 2 and down instead of 8. I'd have to go down 8 times 2, which is 16, and I don't think I have the space for that. But I can kind of see this is what is happening with my graph. And then our last question says, given the parent function f of x equals the cube root of x, select the written equation, describe the transformations by checking, and then graph the transformed function. So let's pick the right graph, or sorry, let's pick the right equation. We have -2 outside, so that needs to go outside, and it looks like it is on all of them. We don't have anything in front of f, so there should be nothing out in front of the cube root. So this one can't be right. It's got a 1/2 in front. This one is okay, okay. This one can't be right, so it's got to be a middle one. 1/2 x plus 1 needs to go inside. Well, it is here and it is here as well, but the only difference is one is being cubed and one is being cube rooted. So we need to go back and look at the parent function. I'm supposed to be doing the transformations for the cube root parent function. That would be answer choice C, the third one. So I will explain my thinking about why we picked what we picked. My reflections that are happening, well, this -2 definitely is vertical, so that means that we are shifting down 2. So I'm going to go find down 2. Shift down 2 units. There we go. Okay. So we took care of that, and I'm going to write some things in my graphing space because I feel like I need to write some things down and I don't really have a place to do it. So I'm going to recopy my transformation function. +1 -2. So we took care of this right here. We know that the graph shifts 2 units down. Now, we also know that there's some kind of scale change happening, and there's a shift that's horizontal in there. So we need to figure out what's going on with that. And remember that if you ever have a coefficient, you need to divide by that coefficient. So we've got the cube root of 1/2 times x plus, well, 1 divided by 1/2 is really 1 times its reciprocal of 2. So 1 times 2 over 1, that's 2. And then we still have that -2 out here. So really, we're shifting 2 units to the left. So I need to go find shifting 2 units to the left. So shift left 2 units. And then the 1/2. Let's talk about this 1/2 in here. This 1/2 is inside of the radical, so it's horizontal. That also means it's a lie. So if you multiply by 1/2, usually that makes things smaller. If it's a lie, though, it's really making things bigger, so that would be a horizontal stretch. Not by a factor of 1/2, because that would make it bigger, but by a factor of its. I'm looking for a horizontal stretch, not by a factor of 1/2, but by its reciprocal of 2. So those are the transformations that are taking place. So now that you've finished your review, that's included all the different types of problems that you might see on the test tomorrow, You might want to go back and review your notes on any topics that you feel like you struggled with. Your progress has already been saved on your teacher's dashboard, and you're welcome to close the tab whenever you feel like you're done. Please email your teacher if you have any questions so that we can help you out before tomorrow's test.